In today's talk, I'd like to discuss a few aspects of the Earth's climate system that we have not gotten to yet. These include the vertical mixing of the ocean, the climate bands around the Earth, as well as a climate map of the Earth, the El Nino, Southern Oscillation as it's called, as an illustration of the suddenness with which climate change could occur, and finally, the geographical effect of rain shadows as another example of how, in this case, terrain can affect climate. Let's talk about the vertical mixing of water. So not only are there surface currents, but there are also currents between the deep ocean and the surface. The current that mixes the surface water with the deep water is called the Great Ocean Conveyor. This current is driven by differences in water density that are caused by differences in temperature and differences in salinity. Salinity is the amount of salt dissolved. Some water is more salty than other water, and we may go into that a little bit. And the Great Ocean Conveyor mixes the ocean about once every 4,000 years. So it is a slow current, but it is important. Don't forget, for you and I, 4,000 years is a tremendous amount of time. But for the globe, 4,000 years is the blink of an eye. The conveyor also redistributes heat. It brings cold water up in some areas, and it also puts relatively water into the deep ocean. And as a result, the Great Ocean Conveyor, as well as surface currents, affect local climates. I've already explained one of those local effects in Europe. Some people believe that the Great Ocean Conveyor is very important in transporting matter and in the storage of matter in deep ocean sediments. And this is still a poorly understood area. If you decide to become a marine biologist, maybe you will get your PhD in the Great Ocean Conveyor and discover something amazing that nobody has ever known before about the oceans. Here is a picture of the Great Ocean Conveyor. As you can see, the red is what's more surface current, and the blue is the cold, deep, salty current. And look, there is one place in the world where water gets submerged, and here it is in the North Atlantic around Iceland, where warm water gets really submerged because it is very dense, because it's very salty. And it gets submerged and then it cools off, and then cool water comes up in two places, one in the Indian Ocean and one in the North Pacific Ocean. Now there are other places where there's upwelling of cold water as well, but the Deep Ocean Conveyor, this thing which cycles once every 4,000 years, this is our current understanding of it. To understand the Earth's climate, we have now seen a number of effects, and clearly you're not going to have the understanding that somebody who spent a year or three in a university studying climate would in a meteorology program. But you will now understand that the combination of latitude, precipitation patterns, seasonality create climates. And climate scientists actually describe 5 climate types. They are tropical. In tropical climates, the average temperature is greater than 18 C, which is about 64 degrees, so average is greater than that year-round, and there is more than 59 inches of rain. Dry climates, which have low humidity and low precipitation, probably where deserts or semi-arid regions are going to occur. Temperate regions, where you have warm, humid summers with thunderstorms and relatively mild winters, and I know you don't think our winters are mild, but that's just because you've never lived in a continental climate. If you go to college in the Great Lakes, you will learn what a continental climate is, which is warmish to slightly cool summers and very cold winters. And then you have, so think Maine, Minnesota, Michigan, Montana, all of Canada, all of southern Canada. And then finally polar climates. And even in the summer, the temperature rarely gets above 50 degrees F. So those are polar climates. Each of these 5 types of climates is broken up into numerous subtypes, and I'm, of course, going to show you a climate map. And here you go. The first map I want to show you is these bands show you roughly the 5 bands of climate. The orange here in the middle is tropical, then just above them on either side is the yellow band of dry, and then just above them is the temperate band of green, and then above them is the purplish band of continental climates. And then at higher latitudes, whether you're in the north or the south, are the polar climates. And I just want to say, you might get why this band of yellow is here, this dry climate. Because remember, that's where the two cells meet, the two Hadley cells meet and come back to Earth. And those are both very dry masses of air that are coming back. And when they come back down, they get compressed. And as they get compressed, they heat up. So they create hot, dry air. And that is a recipe for evaporating water out of the soil and reducing plant growths. So at about 25 to 30 degrees north and south latitude, we will see there is a band of deserts around the world. Here you see the latitudes associated with each of these, the tropical from about 0 to 15, dry from 15 to 30, temperate from 30 to 45, etc., etc. These are approximate. It's good to know them approximately. And here it is. What a beautiful climate map. And what's interesting about this one is it's animated because it's got a prediction of what climate change is going to do to the climate. So if you look here, the blue is all tropical climates, and they have the prefix A. Those with the prefix B are all dry climates. Those with the prefix C are all temperate. Those with the prefix D are all continental climates, and then with the prefix E, those are polar climates. So you can see, here's what it looked like from 1980 to 2016, and here is the prediction for about 100 years from now. I'll let you watch this for a few cycles, and then we'll move on. Okay, here's a stationary climate map in case that was driving you a little bit crazy. And I just point out this line, and I'm not going to explain it, but this is called the thermal equator. And you can think about what the thermal equator must mean. That's an interesting concept. But you can see here the different climates in the world. Tropical wet, semi-arid and desert, Mediterranean temperate climates, cold temperate climates, polar climates, etc. You can look at this map to your heart's content. I can spend hours looking at this map and then looking at a political map as well to see what countries are where. Next, I want to cover several topics that I didn't really know where to fit in, but I thought you should know. One is called El Niño. It's also called the Southern Oscillation. So sometimes it's called ENSO, El Niño Southern Oscillation. And it really is this phenomenon that is an amazing interaction between the ocean and the atmosphere. And it's really a demonstration of how sudden climatic change can occur when you get a radical shift in ocean and wind patterns. And it occurs when there's large-scale warming of surface waters in the tropical eastern Pacific Ocean. And it's caused maybe by a change in pressure over Australia, so nobody really knows what causes it, which causes wind direction and hence ocean currents to change and warm water to move east across the Pacific towards Asia. And this prevents upwelling, which is pictured in this picture, on the western coast of South America. So normally the winds blow this way and they move the water this way, and that brings cold, nutrient-rich water up. And it affects global weather patterns, just this one change. So I'm going to show you a little bit about this in more detail. Here is a picture of the Pacific Ocean. And you can see that what happens is in Western Asia, you get normal conditions, you get warm water. This creates a low pressure system, so wind blows this way across. And then you get that upwelling off the coast of South America, etc. The westward blowing trade winds keep the warmest water in the Western Pacific. This causes upwelling of cold water in the Eastern Pacific. Results in an amazingly productive fishery. The winds coming off the mountains in South America are very dry, and some of the driest deserts in the world are along this western side of South America. During ENSO conditions, the trade winds weaken, the warm water flows back across the Pacific. This stops the upwelling and therefore kills a lot of fish, and a lot of people get unhappy because they can't make money on fish. And then warm, wet winds push east into the Andes and cause torrential rains on the eastern side. And not only that, the weather in all of southern North America is affected, and we get warm, wet winters in North America as well as in other places. So, what does this have to do with climate change? El Niño is caused by changes in ocean currents that impact weather around the world. Currently, El Niño is a periodic condition, but if such a change were to persist, it would change climate permanently. One of the predictions of climate change models in response to a warming planet is the change, perhaps permanent, in ocean currents, and thus there would be large, unpredictable climate effects that we would have difficulty understanding. In other words, these would be emergent properties that are unpredictable. We could not understand until we actually see what happens. Finally, the last effect I want to show you is this idea of a rain shadow. When moist air come off an ocean and they hit the mountains forces the humid air to rise, and as it rises, it cools, and therefore the vapor condenses, and you get clouds forming and then precipitation. That means on the leeward side of the mountain, downwind side of the mountain, now there's very dry air coming over it, and as it comes over the top of the mountain and goes back down to a lower altitude, it is compressed and made warmer. And so you get a desert, or what's called a rain shadow, because not much rain makes it over the top, on the leeward side of the mountain. And how much of a phenomenon can this be? Well, if you look at the Great Basin in the western United States, you'll see how big it is. But I want to show you the biggest rain shadow of them all. Does anybody recognize where this is? Really an amazing geographic feature. This must be, from here to here, must be at least 1,000 miles, if not more. This is huge. Yes, if you guess that these are the Himalayas, you're correct. And this is southwestern China, which is incredibly dry. When the monsoons come to this part of Asia, you get a tremendous amount of rain. The Himalayas cause desert conditions to their north. Atmospheric moisture flows from the Indian Ocean. And as I said earlier, another example of this rain shadow effect is the coastal range of the Pacific Northwest and California, which causes deserts to the east. Well, that's it for today's talk. I hope you feel that you have a much better understanding of the Earth's climate system, and you have a much better understanding of what climate itself is, and the various atmospheric, oceanic, astronomic, and geographic features that affect climate. In the next lessons, we will go on to look at climate change and how humans have put so much carbon dioxide, so much greenhouse gas into the atmosphere that we are now threatening to change relatively stable climate systems and enter highly unpredictable territory. Until that time, study hard.